because some sensors they have hysteresis. You find that when the data is reducing and when it's increasing, you get different values, and this can bring problem in some projects that need accuracy. Someone asked their mics unmuted. I don't know who's that. Oh, it's already 8:30. I need to go faster. It's already 8:30. Drift, the change in output over time with constant input. So with over time, you find that as you're using a sensor a number of times, you can find that at maybe temperature sensor at 20 degrees, it was reading maybe 19. Then after some time at that 20 degrees, you find its reading changes. It changes from 19 to maybe 18. That's a sensor that is not really accurate, so it's not measuring the 20, and it also has drift. So the physical temperature has not changed, it's still 20, but you find the temperature reading after some time it changes. That's the drift, change in output over time with constant input. Noise to signal to noise ratio, something that really affects analog sensors. So sensors usually pick up, analog sensors usually pick up background noises. So it's the ratio between the desired signals and the background noises. And operating environments, each sensor has its own operating environments, be it the temperature, humidity, moisture, that's humidity, etc. Yeah. Yeah, the voltage it needs, though that's it's not environmental, but it's another specification. The power consumption, yeah, that's power consumption, energy required for the operation. So when you go to any data sheet, you'll find for any data sheet for any sensor, you'll find that these things must be specified. Every sensor, majority of these things, it's usually laid out there. Okay. So let's look at the different types of sensors that are out there. So there are a lot of sensors, but I try to group them together so to like cover a huge number at once. So there are environmental sensors, and these are sensors that measure atmospheric and physical conditions. This deals with physical condition, be it temperature, humidity, pressure, air quality, though those ones I put them in another bracket. So the sensor types for temperature, these measure ambient or surface temperatures. That can be, okay, ambient is the temperature in the air, surface, maybe in the ground. And this is DHT, this DHT11, DHT22. DHT22 is this one. I don't know if you can see. Yeah, this is the DHT22. DHT22 measures the temperature and humidity. DHT11 measures only temperature. I don't know why I didn't add it. I forgot the DHT11. There is the LM35. So is this a DS? No, I don't think so. Yeah. These are humidity sensors. Humidity sensors basically measure humidity. These sensors are usually used in cases like greenhouses, where you need to measure these conditions to know how your crops are faring. Yeah, so you can use a DHT22. Yeah. Another one is the pressure sensor. They measure barometric pressure. Yeah, I think these are self-explanatory. Examples are this BMP 180. Yeah, basically they just look like too tiny. I don't. How many have interacted with any of the sensors that are here? A pressure sensor, the BMP 280. These are things that measure barometric pressure. They look like a barometer, if I can just say that. Use cases, temperature sensors. Okay, any use case that you need to measure like physical temperature condition, be it a greenhouse, be it a fish pond, be it a granary, be it a farm. Yeah, so these are the environmental sensors that are out there. And each sensor has its own like communication protocols. Some use UART, SPI, there's the I2C, but these are things we look at later on. So I didn't see the need to like look at what each sensor uses, because we have not covered that yet. There are motion and proximity sensors. This detect movement, orientation, and distance of objects and people. Yeah, from the name itself, motion, proximity, and the sensor types, they are passive IR, infrared, or PIR sensors. What they measure? It measures infrared radiations from body movement, and an example of this sensor is the HCSR501. This one here. I don't know if you have seen these bulbs that are motion sensing. They turn on when someone is close. They work with this, the HRSR501. Yeah, use cases, motion detection, security systems. They read the IR emitted from a person's body. There are ultrasonic sensors. These are using sound waves. They measure distance to an object using sound waves. There's a transmitter, there's an emitter and a receiver. One sends the waves, another one receives them. An example being the HRSO5. It's a really cool sensor. Like, I have it like right here next to me. I would have loved this session to be like physical. So like I can have physical like components. You can like distribute, people like look at them, interact with them. But yeah, we just work with pictures for now. So ultrasonic sensors, they're used in optical detection, being AGVs and such kind of AGVs are automated guided vehicles. Yeah, parking systems usually use ultrasonic sensor to know if there's a car there or not. Another step of motion sensor is the IR sensor. You know, there's the passive IR and there's the like IR itself. So this used to mesh to what it measures is the proximity or object detection. Yeah, basically similar to ultrasonic, but it's using a different technology. Ultrasonic uses light. This one uses infrared. And an example of that is the TCRT 5000. This one, no, this is an IR. I don't know if yeah, it's this one. It's this one. Yeah, yeah, it's this one. This is the sharp IR. Yeah, I think so. Yeah, I've not interacted with this one. Majority of this, you just find it this little part here, but some of them you find them that they have some ICs integrated with them, but it can work with them either way. It's just depending on like the project you're working on, how you need it. Like, you know, some projects are space constricted, so you just work with what you need. So use cases, there can be line following, robots. Yeah, that's a project I did for my internal attachment. We built an HGV. It was working with an IR sensors it was working with an ultrasonic and IR sensor, ultrasonic for object detection, objects in front of it, IR for path following. Yeah, cool stuff, cool stuff. Object counting, though, okay, they are not popular for object counting, but it's also a use case. Another one is accelerometers. These are used to measure orientations and acceleration. An example of that is the MPU 6050. This one here. Basically, they used to measure the orientation, how things, if things is like upright, its angle, its tilt, and if it's moving. I know some friends of mine who used this sensor to work on a device that was sensing people with epilepsy. You know, epilepsy, kifafa, where people just like fall and start shaking. So they were using an accelerometer, this sensor at the MPU 6050. So it was measuring those shaking motions and knowing when someone has epilepsy, is having an epilepsy episode or not. Yeah, you see, it's that sensors usually come in handy. This is the ADX 34 345. Okay, I won't lie, I've not interacted with this one, but yeah, it's also an accelerometer, and it's used for gesture detection in mobile devices. These are your games where they have the tilt to control. They usually work with accelerometers and wearables. The device that my friends were working on, it was a wearable device and it used an accelerometer. Yeah, so you can see how these sensors are being used. Another type of sensors is optical sensors. I hope you're together. Are we together till now? Another type is the optical sensors. These sense light intensity and respond to visible or infrared light. So the types of these sensors is, the first one, the LDR. and it measures light intensity, usually working with resistance. So when light falls on it, I think it yes, it increases the resistance. So that change of resistance is detected, and they used to like the reading is used to do something depending on your project. Yeah, example of that is the GL5528. This one here, it's pretty popular. I believe even if you've not interacted with it, you've seen it. They're pretty popular. There's this one. This one is it's a pretty advanced one, but it's also in the market. It's a more it's an upgrade to this one. Yeah. So use cases, light sensitive lamps, those lights that turn on when it's dark, they use the LDRs. Okay, some use LDR. Okay, not really LDR, but some use them. Depends in the project again. Yeah, another optical sensing sensor is the photodiode. Photodiode, this one here. Yeah, it measures light intensity. All of them measure light intensity. Yeah, this is the BPW34, this one, as you can see it. This is IR sensor. Our sensor, these others work with the visible light, but our sensor works with infrared. Yeah, usually have the emitter and the receiver. I don't know why I'm confusing emitter receiver with the transmitter and receiver. It has the emitter, which emits the infrared, and the receiver receive them. Usually measure. Your remotes have this. If your remote, if you like try to press your remote while looking at it with the phone camera, you can see the IR, the infrared light from it. Yeah, then your TV has the receiver, another IR sensor, the receiver. Yeah, so yeah, they're pretty cool for, okay, depending on the type of project you are working on, you find that you might need optical sensors. If your project involves light in a way, yeah, so these are the sensors that you'll be looking at. Though there are so many. Okay, these are the ones that I highlighted, the 4 of them, but light sensors, there are so many. Yeah, biometric sensors. Biometric sensors. That's our 4th like group of sensors which we'll be looking at today. These are used to detect biological signals for identification and health monitoring. It's biometric, so obviously it's biological. So the types of these sensors is the heart rate sensors. These are sensors which measure pulse or beats per minute, BPM, like the Max 30-100 and 30-102. Is that 102? Let me look at it. Yeah, I think it's the 3102. If you if you look at your smartwatch, you can like see this it works using IR. It also works using IR. So basically, most of the heart rate smartwatches work with these sensors. Even you can see the use cases, the fitness trackers, medical wearables. Yeah, they work with the Max 30-100 and the Max 30-102, these two. But there are others, but I cannot highlight all of them because there are a lot. And I've not worked with all of them. I've only worked with this one. I worked on it with a project called CareSync. CareSync, basically, it was a project where we worked on a GPS tracker, which also included a heartbeat tracker. So as you monitor where the location of your heart, this was to be used in these areas with cattle rustling, etc. As you monitor the location of your heart, you can also see like its health condition, if it's still alive. Sometimes you can find you're chasing something that was already like slaughtered. So yeah, it included a Max 30-100. We work with that. Yeah. Another one is the fingerprint sensor. This one I've worked with in Go Technologies when we're building our clocking device. Basically, like your fingerprint sensor in your phones, same concept. Yeah, just reading fingerprint patterns and using that fingerprint to like verify someone's identity. Yeah, we worked on it in Go Technologies. Our startup that I mentioned, we have our first our first product, which is the uh, GOT GN1 clocking device. It's a biometric clocking device. Same concept is used by the staff for clocking in and clocking out. Yeah, so that's why we applied this. Okay, for each sensor, I would be like trying to give you like a use case, so like you can see how it's being applied in the world. So like for each, I'll try like to give a use case where I saw it being used or how I used it, so like you can get a better understanding to how how and where to. Wow, we need to go faster. It's 8:45. Gas sensors. There are different types of gas sensors which measure gas concentration, be it CO2, CO, uh, methanol. Okay, how is gas? Is it methanol? Yeah, methanol, dust, etc. There's the MQ2, MQ2, MQ5. There's this MQ series. You can see them. MQ2 measures combustible gas and smoke. MQ3 alcohol. MQ4 methane. Yeah, methane. Methanol. Yeah, methane, propane, etc. Yeah, you can see. I'll share the slides after this. You look at them. There's also the CO2. CO2 can be measured. It can be categorized as a gas sensor. Yeah, but they are like specific gas sensors that are built for measuring carbon dioxide levels. An example of those being the MG811 and the MHZ19. Yeah. Use cases, indoor quality, anything air quality, that's where they're used. Yeah, other sensors, these are sensors that don't really fit in those categories that I created, but are still commonly used in electronics and IoT. One being the Hall effect sensor, which is using the magnetic fields. There are these ones, the A3144, SS49E, yeah. Speed sensing, use cases, speed sensing, gate detection, brushless. Okay, I've not worked with all sensors. Touch sensors, measure physical touches, yeah, like this one here, uh, used for touch buttons or user interfaces. Yeah. Sound sensors. Sound sensors are basically normal microphones. Like a microphone is a sound sensor. Yeah, they measure sound levels. There's the KY 038 and generic microphone. Use cases on activated devices, noise detection. Yeah, I believe touch and sound are self-explanatory. Hall effects are in some situation where maybe it's a ferromagnetic uh, object. So if it's a ferromagnetic object, you use an Hall effect sensor to like detect it. So that's the use case. What are actuators? So actuators, we have looked at sensors. We've looked at sensors. So now we move to actuators. So actuators are like the opposite of sensors. So sensors, they convert physical properties to electrical signals. So actuators are the opposite. These are devices that convert energy, typically electrical, hydraulic or pneumatic, into mechanical motion and physical action. So they essentially form the muscle of a system. So systems need to do something. So these are the ones that provide the action, responding to control signal to create physical changes in the environment. You can see like there's some two pictures of like actuators here, but we look at them. So how do they work? How do they work? First, they receive the electrical signal from the microcontroller or PLC or whatever computer or whatever system you're using. They receive the electrical signals. So they convert this electrical signal into, okay, it depends on the type of actuator, the different types. If it's a mechanical actuator, they convert it to mechanical motion, to, if it's an LED, it converts it to light, sound, and other effects. Okay, it's not only physical motion, it can be light, sound, anything like that interacts with the environment, not only motion. Yeah, so they convert into mechanical motion, light, sound, and other effects. Then, so when that motion happens, if maybe it's a motor and it rotates, so when it rotates, an action it's happened, an action is executed in the real world. Maybe it moves a robotic arm when a signal is received from a microprocessor, then to that motor moves a robotic arm. That's an action executed. Yeah, from the name itself, actuators, it produces an act. and some systems may have a feedback. Those closed looped, there's open loop systems that don't have feedback, but closed loop systems have feedbacks where there are some sensors that provide like a feedback that that action has been done. But open loop don't have feedback. An action can not happen, but the system just assumes it happens. So there's also a feedback where it uses another sensor to provide the position of the body after an action. So yeah, you can see I have an hydraulic linear actuator. You can see there's a fluid inlet. So when you need to like to move this is using hydraulic, not necessarily electrical. So the fluid comes inside via here, then it pushes this piston, and maybe this piston it moves a component or something there. You see, it has created an action. This is it called two-sided? I don't know, double action. Yeah, double action. It can move this side when fluid comes from this side. It pushes this side to retract the arm, the piston, and when it comes to this side, it pushes it forward to extend the piston. Yeah. So basically, that's how actuators work. It may be electrical, hydraulic, or pneumatic. Yeah. So what are the types of movements or traction produced by actuators? It can be linear motion. These are movement in straight line. Some situations just move. Maybe it's in a conveyor when maybe a box it reaches a certain place, it's pushed out of the conveyor or pushed to another conveyor. So that's where you use linear motion. Linear motion is required. Example being solenoids, linear actuators, and hydraulic pistons. Hydraulic pistons being this one here. Linear actuators. These are linear actuators. These are linear actuators. Okay, I don't know why the slides are not coming out where. These are linear actuators. These are linear actuators. And they produce linear motion used in door locks, drawer system, robotic slides. It can produce rotary motions where it's spinning or rotating an object. Example are these motors. I believe everyone here has interacted with a motor. Both are different types of motor. There's the DC motor, servo motor, stepper motor. Each has their own use cases. Yeah, but we'll not look at motors for now. That is not the scope of our session now. Used in wheels, fans, robotic joints. It also can produce vibrational motion. This is producing oscillation or vibration motion. This example being a vibration motor, like in your phones, or haptic feedback. That covers, yeah, haptic feedback. Another type of motion or action produced by actuators is the sound output. Signals to audible tones. These are buzzers, speakers, and used in alarms. I think this is like self-explanatory. Light output. These are LEDs or like normal bulbs, which turn electrical signal, electricity to light. The bulb is an actuator in your house, and even you don't know that's an actuator. They're used in like displays, used in alerts, and other user feedbacks. Thermal output. These are actuators that convert the signals to produce heat. Examples, the heating elements, Peltier modules, etc. They're used in smart thermostats, incubators for maybe chicks, etc. Yeah, because incubators keep track of the temperature. It has to be maintained at a certain range. So let's look at the type of actuators. These are self-explanatory because I've mentioned majority of them, so we'll just like skim through them quickly. There's the electrical mechanical actuators. These are actuators that convert electrical signals to mechanical signals. Example being the normal motors, DC motor, a DC motor like this one, the industrial motors, but as for IoT, we don't really look at just the tiny ones that are used for DIY projects. Action continuous relation. Yeah, there's the servo motors and the stepper motors. I believe motors are electromagnetic actuators are self-explanatory. You can just like think of where they're used. They are the pneumatic and hydraulic actuators. So pneumatic is air. Any actuator that uses air is a pneumatic actuator, and hydraulic actuator, the one that uses liquid, is an hydraulic actuator. They produce linear or rotary motion using the fluid, either air or liquid. Actuator types, there's the pneumatic pistons, these ones here. So this is the double action. You can see when air comes from this side, it pushes this piston to this side, and this produces a linear motion. Yeah, when they want to retract it, the air is pumped in from this side here, then comes in pushing this piston here. I don't know if it makes sense. Then there's the hydraulic cylinders, same concept, but change the fluid. It's not air anymore. It's hydraulic. Hydraulic is used for projects that they are for heavy lifting, because liquid oil has higher density than air, so it's able to transmit energy at a better rate. Pascal principle. Yeah. Another is like actuators. Yeah, these are normally LEDs, buzzers, and speakers. I believe this is self-explanatory. So because of time, I just like skim through. Yeah, LEDs produce light, buzzers they buzz, produce sound. Speakers they produce audio, which is still sound. Yeah, and this sound affects the physical world. Light affects the physical world. So they're producing an action to the physical world, making them actuators. Other actuators, solenoid locks, yeah, this one here, a solenoid locks. It's used for linear push and pull movements. An example being door locks, vending machine. Basically, if you've done physics, you know what's a solenoid. It's a wire wrapped on a metal. So energizing the wire produces some electromagnetic field that maybe release or do something. So that's the concept on the solenoid. The relay work with a similar concept to solenoid, but these are just two circuits together. Yeah. This one here is used to switching high power devices. Relays are more like switches. They're like higher level switches. Yeah, used for home automation and AC device control. The linear actuators, these ones here. If in robotics or in the industry, these are things that you will see a lot. So they're used for motorized linear motions. Example is the generic 12 volts actuator. This one, the majority of them look like this. Used for adjustable beds, robotic sliders. Yeah, I believe those are all the actuators. So how do they work together? How do they work together? From seeing how what a sensor does and what an actuator does, I believe like you can get like a sense of how it works together. So the first thing is the input, the sensing of the physical changes. So a sensor detects physical changes in the environment, e.g. temperature. So yeah, example being a temperature sensor measures the room temperature. Then this data is sent to a microprocessor for decision making, the processing. So microprocessor reads the sensor data and decides what to do depending on your code. So if the temperature is above 30 degrees, turn on the fan. So in our case, the fan is our actuator. The sensor reads the temperature, sends it to the microcontroller. The microcontroller decides what to do. If the temperature is higher than the 30 degrees, sends the signal to the actuator. So the actuator receives signals and perform a real-world action. In our case, microcontroller sends a signal to a relay to turn on a fan. So the fan is turned on and the temperature is reduced. Yeah. So in this case, it's a closed loop. So that as the temperature reduces, the sensor still picks it up. When it goes below 30, sends send the data to the microcontroller turns on the fan, and yeah, it's rinse repeat, the same process. I hope you have understood. Okay, I have this diagram. The text is using temperature. No, it's using a fan as an actuator, but in this case, you're using the case of maybe a fire. If it is a fire, the temperature rises, so the temperature sensor detects heat, sends the data to a control signal. The control signal decides what to do. Then, in this case, the actuator is a sprinkler, which sprinkles water to turn off the flame, to put out the flame. Any questions so far? Any questions? I think someone has their mic muted. Okay, if there's no question, we'll move to our demo. Okay, for our demo, I did like a small project just to demonstrate how a sensor and an actuator are working. So I did a small project in Wokwi. For those who were in our first session, I introduced Wokwi. Wokwi is an online simulator for ESP32. That's why we'll be doing most of our projects because we cannot do it in the physical world, so we do it on Wokwi. So let me just share the screen to Wokwi so you can see this project. It's really it's a simple thing. It's a simple demo. It's nothing complex. Can you see my screen? React if you can see my screen. Can you see the Wokwi interface? Nice. So this is Wokwi. Wokwi is an online simulator for ESP32 and etc. Oh, I did not stop the simulation. Yeah. So basically here, let me close. So here we have an ultrasonic sensor and a servo motor. So our ultrasonic sensor is the sensor. It's an ultrasonic sensor, and our servo motor is the actuator. So what's supposed to happen? This is supposed to work like a toll gate. So when an object is less than 20 meters, this servo motor is supposed to act like a gate and open, like turn 90 degrees. If you can see our code, I don't know if how many are conversant with C, but this is just simple Arduino code. Yeah, it's Arduino code. Yeah. So you can see the trigger pin, like the ultrasonic works with the trigger and echo. Yeah, the servo pin. You can see the connection. These are the data pins. The trigger pin goes to pin 12, and the echo pin goes to pin 14. The red pins these are the power pins, the ground. You have to ground it. Yeah. And the servo only works with pulse modulation. So this is the data pin, this is the power pin, this is the ground pin. Yeah, basic connections. Yeah. So let's run the simulation. So just to like see how like a servo works. So you can see like currently, this ultrasonic sensor measures a distance of 73 meters. So when maybe let's say a car is approaching a gate. Let's just imagine this is a gate. So when a car is approaching the gate and it reaches a distance of let's say 20 meters, the servo is the data is sent to the microcontroller where you see the distance object detected. The distance is 60 meters. This distance is less than 20 meters, which I've set here. Okay, I know we haven't covered the coding part, so I will not like focus on the code to avoid like confusing people here. So let me just do that, stop, recompile, but don't focus on the code as much. But if you're bothered with it, no problem. I share the code and everything, but for now, let's just focus with how it's working. It not compile. Oh, I canceled it. I canceled it accidentally. So as we wait for it to compile, any questions so far? Wow.
Hello. Okay. I'm Daniel. And
Yes.
okay. And okay, I've been working on a project where I needed this linear actuator, and actually, of which I don't know if there is any shop you can refer me to.
Oh yeah, sure. There's there's Nerokas. There's okay. What type of okay. Currently, I'm sharing one tab. Let me share like my whole screen so like I can show you where you can find your actuators. There's this online store. It's called okay. I'm multitasking. I'm not usually great at that. It's called the name. It's called Pixel Electric. let me type the name on the chat. It's called Pixel Electric. It's like a junior, an online store for. Can you see my screen? Yeah, I think you can see. Yeah, this. No, it's not this one. Pixel Electric. So you can see here they sell different types of actuators. Oh, you said you needed a linear actuator.
Linear actuator. Actually, I've been looking for it on almost every shop here.
Yeah, you see they're here. Yeah, here is one, but it's expensive. 40. Okay, it depends on your pocket. Okay, but yeah, this store. Let me share the link to this store in the chat. Let me share the link. This is Pixel Electric. Here you can get any component you wish. It's a nice store. They have different different boards, sensors. You can see here there are sensors, there are drone parts, there are 3D printer. They sell 3D printers and CNC machines. They anything electrical, any component you can find here. There's also another option. There's a company called Nerokas. Nerokas. This is also where you can find linear actuators. But the thing with the Nerokas, I've noticed that their search bar is not that good. The search bar is not that effective. So when you want to find a component in Nerokas, I can advise you like to search linear actuator Nerokas. This is a better way of searching in Nerokas rather than searching in their search bar because it's not really that good. But you can also here you can find any type of component you want. Let me also share a link to that. So have I answered your question?
Yeah. Just a section because I had another simple one. And talking of the sensors, before you conclude, there is this sensor, the brainwave sensor. I don't know if you are familiar with it.
The brainwave, pardon?
Yeah, the brainwave sensor.
Brainwave sensor. Not really. I don't think even it's okay. I'd admit this is the first time I'm hearing about it. What does it do?
Actually, brainwave sensors. It is it is like an example. Maybe you can program it in a way that it is you must train it with a ML. But what you think? There's a way that it happens somehow. Depending on how there is some behind the science there.
So similar to what that Elon Musk company is doing, Neuralink. Also, there's this company Simlink. They usually do cool stuff in like is it Simlink? Not Simlink. What's their name? Okay, I don't remember but there's this cool company that usually build sensors in regards to like biomedical things like brainwaves, etc. Pardon?
Neurochips or what?
Not Neuralink. Neuralink is by Elon. I know Neuralink. There's another one. It's Sim something. I think I've bookmarked their site somewhere. Synchron. I meant Synchron.
Oh,
Synchron. They also are cool, like in the same like specs as the brainwave Neuralink, where they make uh, components and devices that like are able to like interact with your thoughts. I don't know, it's not opening. Is it the site that is bad or my internet that is poor? But it's a cool. They're a cool company. You can check them out. They usually build some pretty interesting stuff. I follow them. I usually follow their work. You can see even have their site tabbed, bookmarked. I mean bookmarked.
okay.
Why is this chat not opening? Okay. Any question? Okay. What was your question on Brainwave? Were you asking where you can get it, or I don't know if I've answered you.
Then actually, I want maybe I can
Yeah.
leave some of you with a task. Maybe uh, if we can, there is a way that we can reduce maybe noises in an office or something. So I wanted to make this a neural chip whereby we can be communicating just by this the waves when there is nothing like hakuna kuongea completely ni natumia
Oh,
waves.
yeah, yeah, yeah. Things that you usually see in sci-fi, you want to bring them to real life. That's big thinking. I like that. I like that. So
No,
that's why I use your brain. Do you have the brainwave sensor?
actually, I'm working on the material, making the chips.
Let's see if the okay. Personally, I'll admit this is the first time I'm hearing about brainwave sensor. Yeah, brainwave. But I think it's a cool project. It's a cool project. But I think components like those that I believe that they're using a high level technology. They're usually pretty expensive. So acquiring that may be hard. But it's a cool project. I like to be involved with that. So DM me and we can see how we can proceed. Oh, so we are waiting for. I don't know why this Goku is not working anymore. But I don't know. Maybe this file is not saved. Oh, I didn't save the changes. So let's try to simulate again. Oh, this demo is just to like showcase how the sensors and sensors and actuators are working. So when the distance is below 20 centimeters, this ultrasonic sensor is able to like pick up that distance and send the data to the microcontroller, and the microcontroller turns the servo motor by 90 degrees. So basically that's how sensors and actuators work. I changed the distance to 30, so that I'm trying to recompile and see if it works. Then our demo will be complete there. Then we move to like a Q&A. Then we focus the session to answering your questions and any. Yeah, I think it has compiled. Yeah. So you see at 95 centimeters. When we go below 30, see below 30. Yeah, you see now it's working with 30. So basically, these are sensor, these are actuator, these are microcontroller. Basically, that's how sensors and actuators work. I hope you are together. Are we together? I can download this file and share. Where do I download? Yeah, yeah. I'll share in the group after the session. Yeah. Okay. So now we move to our Q&A. Even I'd forgotten I have slides here. Yeah, Q&A. Any questions? Any questions? Okay, Dan had asked a question on the brainwave sensors and how you can use them in the school project for communicating telementary. I think it's called telementary communication, communicating with the mind. Yeah, and basically your sensor, that will be your sensor. In that case, there's no actuator. There's no actuator in this case, but if you're controlling a machine, there'll be an actuator in that case. Maybe you're controlling a machine with your thoughts. Okay, like looking at it in the scope of our session today. Any other question? Any remarks? Anyone wants to say anything? No questions? Anyone wants? Oh, Everton, I've seen you've raised your hand.
Yeah, sure. Let me say that the session has been educative. It's been amazing. But you guys are pros, bana. Unajua, go with the pace of others like me. I'm speaking for myself. I believe, like for me, in my case, mini they are nuko hivi, but I mean, your teaching is okay. Your everything is fine, but like at least it could have some point. Then I hear in our previous session, but generally it's all okay. Imekuwa educative and I appreciate. Nimelearn some 1 or 2 3 things. Nimelearn telemetry. Hata sijui ni nini tutaringiana nayo. Thank you.
Yeah. Telemetry communication is basically speaking with your mind, brainwaves. Like if you've watched X-Men, Professor Xavier is called Xavier something, the one with the wheelchair, the bald guy. Yeah, it's okay. It's good to see that you've learned something and you're new to this. And okay, basically, IoT 101 is it's for people at different skill levels. If you filled our registration form, you see, I like asked, what is your skill level, beginner, intermediate, or expert? It doesn't matter if you're an expert. You have someone like Dan was done IoT for 3 years, and you're a beginner, and we're all here like learning and interacting and working together. Maybe okay, majority of you we might be meeting first time in one call, but who knows like 1 week from now, 2 weeks from now, we may find like maybe Everton and Dan, you're working on a similar project, Gilbert and Eli maybe combined on something. So, and if you looked at my slides, you see, there's something I mentioned, and I usually like to emphasize on this.
Oh, by the way, one last question. Could you is it possible for us to get, or maybe for me to get the same slides that you've been using to teach?
Yeah, sure. I'll share the slides after this. You see, okay, this point I was trying to drive home about like us learning. IoT is a community series. It's more peer-to-peer. It's I'm also a student. I don't know if I mentioned here. I'm also a student. I'm also learning. I'm a lifelong learner. So we are here to like learn, interact. It's not me teaching you. It's us interacting and sharing knowledge. I don't know if you get what I mean. So if you also have show and tell sessions. Show and tell sessions, by this it means when Dan works on his brainwave project and completes it, he can come and show us what he did. It's not necessarily like teacher student. I'm the one almost always presenting something. It's peer to peer, like a community series. So my goal is like to share knowledge and interact and see people building cool stuff. Because I'll stop sharing my screen because I don't think it's necessary right now. If you look at Africa, one thing that we struggle with is we are producing low quality goods, agricultural products. But why is China growing? Because China is it's more industrial. They're building. Why is Germany, a small country in Europe, but has that, it's among the top 3 in GDP in Europe, but in size wise it's among the smallest. Why is it why is that economy that big? Because they build stuff, electrical stuff, mechanical stuff, machines, IoT, embedded systems, engineering. That doesn't necessarily move to like engineering, the industrialization part of it. Like, okay, my dream is to like have a time where Kenya, currently our number 1 import is machinery and electronic products. Currently, every year in our yearly budget, that's the number 1 import. But my goal, my dream is a time when we are producing our own things. And how can we reach there? It's by sharing knowledge and working together, collaborating, networking, and that's basically the goal of this session. And yeah, I'm looking forward to seeing you guys weekly, and we do great things together. Thanks for sharing that, Everton. Whether is your name Everton, like the club, or a nickname? Just confirming.
Yeah, my my name is Everton.
Oh, cool. So do you support Everton? Okay, that's just by the way.
Manze mani siku zote.
GGMU. Okay, cool. Any other question, remark, or maybe just wishing a good week? Or kutuma salamu. You can just like assume this is a radio station and you want to send greetings somewhere. Okay. If there's nothing. Okay, I think we can conclude there. As for me, I'll just I see Alma, you've raised your hand. You can unmute and share.
So hi guys, I'm Alma. Next
Yeah.
time, I hope to talk on something about hacking, internet